Hi, this is Riaz from Networks Learning. Welcome to Cisco Next Generation Firewall Training Series. In this video, we will take a look at how we can configure high availability on Cisco FTD with two firewalls. We have virtual appliances, and on virtual appliances, we can also configure high availability. This is our topology. We have RGS FTD firewall 1, which is placed over here. We will designate this one as a primary, and the other one which is connected over here, RGS FTD firewall 2. This will be designated as secondary firewall. So before going on to the actual configuration, the configuration of the high availability for FTD firewall is a stateful configuration. It means that it will share the connection tables and all the states of the connections that are currently connected on primary firewall, and via the stateful link it will share the connection information in all database with the secondary firewall. At a time, only the primary firewall will be traversing the data, and it will be processing the traffic for the LAN, and for the LAN traffic initiated from LAN will pass via this firewall, that is currently the primary firewall, and the return traffic will also be passed from the connected primary firewall. In case primary firewall is down, we can set the conditions that in which states should it switch its state to the backup, or in which conditions the secondary firewall should secondary firewall should become the active or the primary firewall. So you can monitor your links connected on LAN and on WAN side. So in case of any of the link that is being monitored by the firewall for HA gets down, the firewall will shift the services to the primary firewall, which is currently the backup firewall. So means any link gets down on primary firewall, it will lose the state of the primary, and the secondary firewall will take the role of the active firewall. The traffic will be processed by the currently active firewall, which in this case would be secondary firewall. So there are some prerequisites to configure the HA in FTD. Before moving on to the actual configuration, let me show you this diagram. This is very helpful diagram that you can use. In this diagram, we have two firewalls of 9300 series. Currently, we have a virtual firewall over here, so there is no difference in the configuration point of view. Here we have outside a link. Both firewalls outside interfaces are in same broadcast domain, and both firewalls inside interfaces are also in same broadcast domain. So you need to place some kind of switching on the in order to combine the domain on outside, broadcast domain on outside and at inside. So in our topology, we have just used the switching mechanism. So we have two switches, the RGS firewall switch 1, RGS firewall switch 2. It is connected with the Nexus 9500 virtual switches, and we have VPC connected configured on with these switches. The reason I haven't configured VPC with the firewall is that the virtual firewalls, Cisco Next Generation Firewall FTD, doesn't support the virtual port channel technology and virtual environment. That's why I have deployed two switches over here that are connected with Nexus, and both of these switches are connected over the VPC port channels. Because I am running the VPC over here at core layer between Nexus switches, and I am connecting these firewall switches with the core layer over VPC port channel. So my inside VLAN will be traversing on these switches, and there is a single VLAN. The port is configured in trunk mode, but this is a single VLAN inside VLAN, and you can see that there is a kind of NVMe network, that the VLAN is available all the time. In case of one of my link is down, in case one of my switch is down, the VLAN is available to the firewalls. There is one chance that the firewall will change its state to the primary firewall will change its state to backup firewall in case this link is down. The primary firewall will lose the connectivity on its inside interface in case this link is down. Otherwise, if any of the link between these switches is down, any link from core layer to these switches is down, there will be no effect on the firewall, and the primary firewall will be in active state all the time. There are only two conditions when the firewall will switch over. In case its inside link is down from this specifically this link, or specifically this link outside. One more thing that in practical environments, most preferable approach is this: you can deploy these firewalls directly with the Nexus if we have the support of the port channel technology. Previously, I configured and I deployed the physical links directly with the core layer, but when I came to know that the port channel technology is not supported in virtual environment in FTD, then I changed this design to this. I employed two layer 2 switches in between the firewall and the Nexus 9500 switches. So previous design was that I was configuring two links with each FTD. From Nexus switch 3, we have two links connecting to firewall 1, and the same link that is connected over firewall 2 was going to firewall 2. Switch 2 is currently connected on switch 2 was going to firewall 2, and at firewall I can easily combine both of these links, that is coming from switch 1 and that is coming from switch 2 at FTD, and combining those links, that will that will have provided us the ability to use all the links at all time, and there would be no downtime. In that scenario, only the firewall, in case our firewall box is down, then switchover will be performed in that condition. But in this condition, if one of our link gets down, the firewall will switch over its state to the secondary, and the secondary will become the active one. So for high availability, you need to have the same resources in terms of the hardware, in terms of the iOS, in terms of the model. These has to be same, and minimum you can configure high availability between firewall is the quantity of 2 firewalls. You cannot deploy 3 firewalls and configure high availability. You can configure only 2 firewalls in HA, so it will be an active and standby. The firewall series that are currently provided by Cisco are 1000 series FTD, and we have 2100 series, 4100 series, and 9300 series. We can configure HA between firewalls on 1000 series and on 2100 series, 9300 series, and 4100 series. However, we can also use the clustering mechanism, and clustering mechanism is supported only on firewalls from series of 4100 and 9300 series. So in clustering, you can cluster the firewalls, and all the firewalls can become active at a time and can load ballistic traffic, and you can deploy firewalls in cluster to a maximum of 8 firewalls. You can combine 8 firewalls into one logical firewall by using the clustering technology in the FTD. So moving on to the configurations, we have inside VLAN for 199, and we have outside VLAN of 201. Currently, all the interfaces of inside and outside are pre-configured, In the routing section, I have configured these routing in my one of my two videos, in which I have explained how the routing functionality is performed on these firewalls with the Nexus, and these firewalls on outside interface with with edge routers. So moving on to the configuration, let me show you the configurations of two firewalls and OSPF neighborship between these inside and outside interfaces. Currently I am not running these Nexus switches, so I have configured SVA interface for inside VLAN on these switches, and I am having an OSPF neighborship between the firewall inside interface and these switches. So let me show you the configuration of these devices. So I have two devices, primary and secondary firewall. I haven't changed the names over on the topology, so kindly ignore that. RGS NGFW primary. NGFW primary. So now the naming convention is correct and is matching with the topology and the configuration. So I have primary firewall and its interfaces are configured. You can see over here I have 00 interface connected to outside zone, and I have sub interface with VLAN of 201, which is 10.10.201.3. Okay. At outside interface of the firewall, I have on primary firewall I have 10.10.201.3, and on secondary firewall I have 10.10.201.4. On inside interface of the firewall, I am connecting on Gigabit Ethernet 0/1, and on inside I have a sub interface created with an IP address of 10.10.199.1 on this inside interface. Similarly, on backup firewall I have 10.10.199.2. I will also show you the secondary firewall interface configurations. Here you can see I have 10.10.199.2 on inside interface of the secondary firewall, and on outside interface of the secondary firewall I have 10.10.201.4. So this is my inside and outside interfaces. Let me show you the configuration on these edge routers. So the VLAN is transversing towards the edge router, and on edge router I am using the concept of router on a stick approach, and I have the edge router 1 over here. Yes, I am connecting on outside VLAN, so there will be configuration with respect to the outside interface. You can see over here 10.10.201.1. So I have 10.10.201.1 on edge router 1, 10.10.201.2 on edge router 2. You can see over here 10.10.201.2 on edge router 2, and on firewall end you can see over here system support diagnostic CLI show interface IP. On FTD firewall 1 I have 10.10.201.3, and on FTD secondary firewall I have 10.10.201.4. You can see over here. On an inside interface 10.10.199.2. On its inside interface 10.10.199.1. So on edge router, on RGS firewall switch 1, which is currently having OSPF neighborship on inside interface. You can see over here 10.10.199.3 for inside VLAN, and add switch to this one, firewall switch to, sorry. I have 10.10.199.4 IP address for inside VLAN. So this is the prerequisites to configure the high availability and the Cisco FTD. And we have two links over here. We have one of the stateful link and one is the lifeline or failover link. In production environment, you are supposed to use separate links for hello packets, which is used the hello the you can say the lifeline link or the failover link. It is used to know the state of each other. Both firewalls will use this link to know the state of each other. Using this link, they send hello packets, and other mechanisms are followed in order to know the state of the firewalls are active or not, and alive or not. In stateful link, you have actually transferred the data that is being utilized by this firewall, primary firewall. The primary firewall sends the session tables, state tables over this link to the secondary firewall, so that the secondary firewall has the clear picture of what is happening on the network, in which connections are currently active and not. And ultimately, when the primary firewall gets down, the connections are not lost. The secondary firewall is turned to active state, and the connection state is not interrupted. The connections are continued on the secondary firewall, and the end user will not face any kind of interruption in the traffic, and it has not to reconnect the session because this is a stateful switchover. So this is the lab, and this was the mechanism behind the configuration of the HA. So now we will move on to the actual configuration of HA. Before configuring HA, make sure you have deployed the platform settings. You have deployed the have basic health policy. So these are some of the prerequisites that you need to perform. I have deployed the RGS health policy, in which I have stated the configurations. And in platform setting, the platform setting is usually used to deploy the parameters that we need to configure on managed devices. In this case, I have two firewalls, and I have configured RGS platform settings for them. In this setting, I have just configured the time setting, time zone, and time synchronization. I have configured the time zone, and time synchronization I am using from the management center. And at FMC, I have configured the NTP services, where I can show you over here in configurations. The system tab is usually used for the FMC settings. You can see over here I have a time setting over here via NTP based on system configurations. I have multiple NTP servers configured over here. I have my own LAN system which is used for NTP, but currently it is not using it. It is using this one which is configured over here. And from time synchronization, you can see that the synchronized time via NTP, and we have configured the NTP servers here. So FMC will provide the NTP services to the managed devices. If you are configuring this technique, then your entire system will be in clear and in synchronized state. If you don't have a synchronization of the time between the FTD and FMC, then you won't be able to get any configuration synchronized, and you will have difficulty in managing this. You will you get a warning and an error every time over here. So before configuring this, you make sure that your both of the devices that you want to configure in HA are in good health condition. So now we are going to configure the HA. So my both firewalls are healthy without any error. So click on add, click on high availability, and name it as RGS FTD HA. Device type is Firepower Threat Defense. Primary device is RGS NGFW primary, and secondary would be RGS NGFW secondary. Click on continue. The operation restart is not secondary devices temporarily causing traffic interruptions. So we don't have any kind of traffic currently running from the FTDs, and we want to configure this HA. So click on next, continue, click on yes. So in this dialog box, you actually configure the high availability pair. We have high availability link, we have state link. High availability link is this one, which is in red condition, and currently we are using 0/8 and 0/7 for stateful link. Here we need to select the interface which we are configuring for which we are using for the high availability link. In this case, this is 0/8 link over here. Its logical name, we can configure a logical name like, let's say, you can say you keep alive link. You can say keep alive link is just a terminology used in the VPC technology. So you can say over here as lifeline. Lifeline is one of the good term that can be used. Lifeline. Primary IP address. We will use the subnets of 192.168.10.1 as high availability link on this primary device, and on secondary device. Be careful that if you are selecting 0/8 on primary device, make sure that on secondary device you have the same link connecting and same port connecting for that link configuration. I have 0/8 on primary firewall for lifeline, and same link, same port on secondary firewall is being used for lifeline, that is 0/8. Here you need to provide the IP address that will be configured on secondary device for the high availability link 10.2 255.255.255.252. Since we only need two IPs, so I will restrict this subnet to /30. So this is the configuration. Now we need to configure state link. In state link we also need to follow the same procedure. You can configure the same as lane failover link. You can configure this as a failover link. This is the good terminology that FTD has already been used in this configuration. So state link can also be configured as same as the failover link, but we will prefer to configure this separate link for the state configuration. 0/7 in this case. Here you can see we have 0/7. The IP address, logical name, stateful link, primary IP address on primary device. What would be the IP address on primary device for this state link? 192.168.20.1, and on secondary device 20.2, and mask is 252/30. We don't want to enable IP encryption in production network, you are supposed, but in a lab environment we don't want to consume heavy resources on our CPU. So you need to click on add. So it will process the request in background, and it will configure multiple processes. After that you will be able to have a clear picture over here that the HA has confirmed and your configuration is okay. This is our lifeline and this is stateful. Okay. Configure interface monitoring options to protect the HA pair interfaces. Apply the same health policy to the primary and secondary nodes of the HA. It is saying that you can configure interface monitoring options. So we will configure once the HA is confirmed. Currently it's working on it. HA configuration, and the process is completed successfully. And we can see over here it took 12 minutes and 29 seconds for HA configuration and applied the policies and other configurations to the secondary device that we configured recently. We can see over here there are a couple of health checks, and it designated the primary, this firewall to be the primary and the other one to be the secondary firewall. So you can get more details about these warnings or in the warning state: failover primary, failover state, standby, failed internet check, interface check, and primary, this one, failover state, standby, interface check. So you need to configure the interface checks for both of these firewalls. Let me go to the HA configuration. Over HA, we can state the monitor interfaces, outside interface, inside interface. Inside interface, VLAN sub interfaces are not being monitored, so we will enable the monitoring for the sub interfaces, that is for VLANs on which we are connected on inside and outside network. We don't want to enable the monitoring for diagnostic link, and we don't want to go for any other settings over here. So let me save the configurations. After saving, we need to deploy these configurations. You can see over here, this will be deployed on HA on both firewalls. Once the deployment is completed, I will be back and will check further with the HA settings. So almost the initial deployment and syncing between two devices has successfully been completed, and we have now the clear picture of the high availability between two devices. You can see over here after configuration the FTD primary firewall RGS NGFW primary is considered as primary. However, secondary one is considered as secondary device, and the traffic syncing between two devices has successfully been completed also. At CLI, you can figure out this configuration with the command show high availability configuration on primary and secondary device. So at this we have failover is on, failover unit is primary. We are currently on FTD firewall primary version. Failover LAN interface, failover link gigabit 0/8 is up, and you can see over here this host is the primary and is active. Other host secondary and is in standby state. So this is how you can configure your high availability on Cisco FTD next generation firewalls. So it's still deploying some settings, initial configurations to the HA. Under HA there was this basic modification in interface policy which I configured, but the FMC by default will deploy all the configured policies that are for active device, and it will deploy the same settings to the secondary added device which is currently in HA. You can also go to the alert section in the monitor section of the FMC, and over here you can click on this and you can read these alerts in the alert section. And it says that secondary unknown failover state standby, check peer events for reason. You can run all the events and it will recheck, so that you have the healthy state over here, and you can mitigate this alert. So you can say that the alert which we was previously receiving has vanished from here, so now it's in normal condition. So same goes for secondary firewall. Rerun all the processes, it will check the health alerts and the state against those alerts, and will provide you the results with the healthy alerts. Here you can see everything is normal now. So status over here is normal. It means that your all devices are synced, up to date, and the configuration is valid. So our primary device, which is NGFW primary, is currently configured as primary, and the state is active. Secondary device configured as secondary, and the state is standby. So that's how you can configure your HA using next generation firewall under FMC. Thank you for watching this video. You can check my previous videos of the next generation firewall training. And in this session we covered how we can configure high availability on FTD.